Okay, so big pictures, we're going to talk some main points of the class so far, or of algebra in general. So the first thing that we have are functions. And with functions, we have function notation, where we have the f or the g or the h. This is the rule. It's the name. It's basically so we can identify what we have. This is your variable. You'll see. Or it'll be what to replace the variable with. And then what we have is we always have an equal sign because that is saying what our rule and our variable or our value is going to be represented by. So what we're going to be using, what we're going to be transforming it, that variable with. So we've got an input, which is our variable or the number that we're plugging in. And then what we're going to do with it is we're going to have this rule and then we're going to get the output. So f of x is the same thing as y. So if you see it, you can say, oh yeah, that's going to be my y. That is my output. Not to be confused. F with the x in parentheses does not mean f times x. It just means I have some rule and the variable that we're going to be using is x. So this is the left side of my equation or my function. I'm only going to use that for notation of seeing what I have. All of my work is going to be on the right-hand side unless I replace stuff. So we're going to get some sort of rule. So let's say that we have, I'm going to say f of x is 3x squared plus 2x minus 5. All right. So we've got it's a trinomial. It's a quadratic because we've got a squared with it. So it's not linear, but it can be any rule, any equation. It's an equation just on the fact that I'm going to be solving it or simplifying it. So when I have functions, I cannot solve a function because I don't have two sides of an equation. I have a name and a definition and a rule that I'm going to be following. But to be able to solve it, I would have to go back to the y equals, or I would have to have it saying it's equal to something else. So functions we can simplify, we can combine, we can evaluate, meaning we can plug in a value and go from there. But function notation means I have a name or a rule, and I have what variable or what I'm going to replace the variable with in parentheses after it. It does not mean multiplication. So make sure that you know what is function notation and then what is arithmetic or working with variables. Okay, so then with functions, the next thing we're gonna look at is when we evaluate them, meaning saying what they're equal when we plug something in for them. So we've given you the f of x, which is the same as what we have with the notations of what it is. And then I've added g of x is going to be 2x plus 7. So it's whatever rule that they want to give you or expression that they want you to say. In this case, we have now a number that we're going to replace the variable with. So whatever's in the parentheses, this does not mean that I'm taking the f function and I'm multiplying it all times 2. It means that in the f function, I'm replacing all of my variables with 2. So this is still just telling me what to do. It is not part of my solution. It is my directions of what I'm going to be working with, and it does not mean multiplication. It just is a notation. They're right next to each other. It means f of 2. And that means that I'm going to take my f function, which is the 3. I come up with an x, and instead of an x, I'm going to replace it with 2. Use parentheses. It's a good idea. And then I have plus 2 times I have another x, which is going to be replaced with a 2 and a minus 5. And I get to simplify this, meaning I'm going to do my order of operations, find out how much it is worth. So this is 3 times 4 plus 4 minus 5. So this is 12 minus 1, which is 11. So f of 2 is 11. If I'm plugging in a -3, I'm going to do the same thing. It's f of -3. So all of my x's this time in my f function are going to become -3s. Be careful with your order of operations. So this is 3 times -3 squared plus 2 times -3 minus 5. So -3 squared is -3 times -3, which is 9. So this is going to be 3 times 9 minus, because the 2 times the -3 is -6 minus 5. So this is 3 times 9 is 27. -6 minus 5 is -11, because they're the same sign. I get to add them together. And then this is 27 minus 11 is 16. So f of -3 is 16. All right, so then the next one that I have is g of 5, which means I'm going to the g function, looking at the g function. Every time I see an x, I'm going to replace it with a 5. So instead of using the f function, I'm using the g. So my g function starts with a 2. I see my x, I'm going to replace it with a 5, and then plus 7. So this is 2 times 5, which is 10, plus 7, which is 17. All right, and then my last one that I have right here, and then I'll give you some other ones, is g of -3/2. So go back to the g function. I'm going to plug in at -3/2. So I have 2 times -3/2 plus 7. Remember, when I'm multiplying fractions, I can either reduce first or multiply across first. So I could go 2 times -3 is -6, and then divided by 2. But I can also, this 2 and this 2 cancel out. One's on top, one's on bottom. So that just leaves me with a -3 plus 7, which is 4. All right, so that's some evaluations with just values. We can evaluate with more than just values. We're going to look at that in just a second. I'm going to clear my screen. Okay, so evaluate can also have me plugging in expressions with variables. So we're going to do 3 more evaluates, which is f of 2m, g of x minus 4, and f of 2x plus 7. So just like we did with numbers, where we've got the directions of what we need to be using, and then where we're going to be plugging in. So this tells me I'm using the f expression. So the f is still 3x squared plus 2x minus 5. Every time I see an x, I'm going to replace it with 2m, keep my parentheses. So I have a 3. And then instead of the x, I'm going to say 2m. And I'm going to have this squared because that's part of my equation, my expression, plus 2. And I have an x, so that is going to be a 2m. And then I have my minus 5. And now I can still simplify, meaning I'm only working with the right-hand side and I'm using my order of operations, and I'm going to just make things a lot easier, see what I end up with. So this is 3, and then 2m squared is 2m times 2m, so this is times 4m squared, and then 2 times 2m is plus 4m. And then I still have my minus 5. I can still do a little bit more work. So this gives me 3 times 4 is 12, and m squared plus 4m minus 5. All right, so I can't actually find out exactly what it's worth, but I have evaluated it using the different input of the 2m, and then I ended up with an expression still. So f of 2m is 12m squared plus 4m minus 5. All right, so then I can do the same thing with my g of x minus 4. I'm going to go in to my g function, which is still 2x plus 7. Start by writing what I have. So I have a 2. Instead of the x, I'm going to put an x minus 4. So this is where the parentheses help, because I still have that variable with an x, but this time it's going to be an x minus 4. So I'm going to replace that, use parentheses. It will help make things a little clearer, just especially when you have the same letter and could possibly confuse yourself. So this is where my variable was, and then I still have plus 7. Now, I still can simplify. Using the order of operations, I have to get rid of the parentheses. There's nothing I can do with that, so then I'm going to multiply, which is distribute. There's no exponent, so this is just going to be 2x minus 8 plus 7. Combine my like terms, which are those constant numbers, so I have 2x minus 1. So g of x minus 4 is the same thing. It's worth 2x minus 1. I can't actually get it down to a number because I still have that x that I was plugging in. All right, and then the last one is a little bit more work. It's the f function. So I'm going back to the 3x squared plus 2x minus 5. And every time I see an x, I'm going to replace it with 2x plus 7. So this is 3, and then I've got my x, so I'm going to say 2x plus 7, yet again, using parentheses because it does make my life a little bit easier. I have the squared plus 2. I have another x, so this is going to be a 2x plus 7. And then I have a minus 5. All right, remember when I have an exponent attached to parentheses and it's not a monomial in there, I cannot just distribute that exponent. I have to write my parentheses twice, or I have to remember that I'm going to have to FOIL. So I'm going to rewrite it twice just so that I remember. So this is 2x plus 7 times 2x plus 7. And then I've got my next terms. So I'm actually going to distribute this because I can simplify it. 2 times 2x is 4x. 2 times 7 is plus 14 minus 5. I have to multiply this out. I'm going to leave the 3 hanging out because I don't want to make bigger numbers. This, a binomial squared follows a pattern, or I can FOIL it out. If we're FOILing it out, just to make sure that we don't lose anything, it's the 2x times 2x. It is the 2x times 7. It is the 7 times the 2x and the 7 times the 7. There is a pattern with this. We can also, because it's the same parentheses, the same exact terms, binomial in there. So there's 2 terms in here, 2 terms in here, and they're the exact same. I can go with the pattern of, I know it's the first one squared. So 2x times 2x is 4x squared. It's the 2 middle terms multiplied together and then multiplied times 2. So 7 times 2x is 14x times 2 is 28x. Now, you could FOIL and combine your like terms and you will get that 28x, but you do need to have that 28x. And then it's the last term squared. So this is plus 49. And then I still have the plus 4x plus 14 minus 5 is 9. All right, so when you make sure you're careful when you're distributing with those binomials, when you're multiplying out, you should end up with the 3 terms, more terms than I have, unless the signs are different and you had like a difference of squares. But FOIL things out if you need to. There are a few shortcuts, but FOILing is always a safe bet. I just didn't have a ton of room. So then I'm going to distribute my 3. 3 times 4x squared is 12x squared. 3 times 28 is the same thing as 3 times 30 minus 2, which is 90 minus 6, which is 84. Yeah, 84x plus 3 times 49 is the same thing as 3 times 50 minus 1, which is 150 minus 3 is 147. Okay, plus 4x plus 9. Now I have to combine my last terms, the like terms. So we have the x terms together, and then we have the plain old numbers. So you end up with 12x squared plus 88, and then plus 156. All right, so that is evaluating. I can't combine any more like terms. I can't get it down to a single number because I was plugging in something with a variable, and we're looking at that. So this is functions with evaluate. We've got more operations we can do with functions. So we're going to be looking at that after I save my screen and put some new information up. Okay, so once we understand how functions work and can evaluate functions and understand that it's not multiplication, but it is a notation, we do have operations. So we can add functions, we can subtract functions, we can multiply, divide them, and then we can do some other stuff with them. But to start with, we're going to add functions together. So the first that we have is f of x, f plus g. So we could write it a whole bunch of different ways. So that they could tell you that you're combining function f and function g. They could say you're going to be adding function f and g, and then you got variable x. So yet again, it's a notation of saying what variable we're going to have. If we start with functions, this is anything that's attached to it is going to start with, is going to tell us what variable we have, especially if it's at the end of what we have. We can do a few other things later with them. So we could like multiply a function by 2 and that kind of stuff as well. We're going to look at some examples with this, but function notation tells me I'm adding function f and g, and then I have variable x. What I really want to do with this is so that it looks like what we have given, because they're going to give us f's and g's and h's or whatever we have. They're going to give us rules. So I really want to think of the two separate things. So I have f of x plus g of x. So meaning I have, there's my rules. I'm going to be taking the right side of what f of x equals, so what its expression is, and then I'm going to add it to the expression of what g is equal to. So not multiplying by x or anything like that. So we're going to separate them into the two functions, and then we're going to be subtracting, going to be adding their expressions together. So if I'm subtracting, I do have to be careful because subtraction order matters, and I would have to be subtracting the whole expression for the other ones. So parentheses are very important, or remembering that you have to change all the signs of the next expression. So f minus g just means I'm subtracting the functions. They could write it as f of g, f minus g of x, meaning that there's the variable x, so they can give you a little bit more information. It kind of looks more confusing. And then what we're going to be doing is write it as those two separate functions and separate them. So f of x minus g of x. I can multiply functions, meaning I can go f times g, meaning multiply function f times function g. A lot of times you'll have to FOIL, so be careful of when you're multiplying and, distributing and all that stuff. So f times g of x, same thing. It's just a little bit more confusing. The only things I'm multiplying are going to be the functions f and g. The x is the variable that I have. And I would rewrite this as f of x, meaning I'm going to take the expression of what f of x equals, and multiply it times the expression of what g of x equals. And then I have also, we can divide. We have to be careful with division. Order yet again matters. And we have one of the cardinal rules of math that we cannot do is the denominator cannot equal 0 because I can't divide by 0. That's one of the rules that we have in math. Dividing by 0 just adds all kinds of problems and confusions. So when we rewrite it, we're going to say it's the f of x divided by g of x. But then there's always usually going to be a stipulation with it, which says g of x is not equal to 0. Meaning I just can't have an answer if it's with numbers where that denominator is going to equal 0, meaning I'm not going to be dividing by 0. So this extra stuff here, the g of x not equal to 0, that is just telling you that it's going to work and it's going to be something that will have a simplification or a solution if I was putting in values to solve. Okay, so we've got some functions now. So f of x is x plus 5, g of x is 4x squared, h of x is 2x squared minus x. And we're going to simplify or evaluate. They could say it either way with problems. And I'm going to do f plus g of x, and then h minus g of x, and f divided by g of x, and g times h of x. So we're going to look at each one separately. The way that I would do it is first break it down to what I am solving. So this is going to be f of x. I'm going to change colors just because I can. Let us use, this color. All right, so this is going to be f of x plus g of x. Now, you can work across if you really want to, but I like to rewrite it as to the expressions that I'm going to be using. Now replace my expressions and then like work from there. So this still is going to equal, so I could put an equal sign here, and then f of x is the expression is x plus 5. So I'm going to put that in parentheses. I'm replacing it. Okay, so I know f of x is the same thing as x plus 5. That is the expression that's on the right. And then I have a plus, and then g of x is 4x squared. Okay, so just replacing with the expressions. Now I don't have any function notation anymore. I just have an expression that I'm going to be combining like terms or putting in standard form. So there are no like terms. So I'm just going to put it in standard form, meaning I want my 4x squared first, and then my plain old x's. So this is 4x squared plus x plus 5. So f plus g of x is 4x squared plus x plus 5. All right, then I'm going to do the h minus g of x. So this is going to be h of x. I'm going to put the red minus sign just so that I remember that I'm subtracting it, minus, and then g of x. Okay. All right, and then I'm going to do it the same way that I did before. My h of x, I'm going to replace it with the right-hand side of what it means. And I'm going to use parentheses. So 2x squared minus x. I do have the minus sign in between there. So if g of x has more than one term, I would make sure that I remember that I'm distributing that negative, changing all the signs. But in this case, g of x is just 4x squared. All right, so I know that I can combine like terms. This is equal. My like terms are my 2x squared and my 4x. I don't really need the parentheses because there is nothing attached to them. This minus is just, there's one term, so it's just the one thing. So 2x squared minus 4x squared is negative 2x squared, because remember the stay like terms, minus x. Right, and that is all I can do. They are not like terms. I cannot smush them anymore together because they don't have the same exponents. All right, then we can go to f divided by g. So this is going to be the same thing as f of x divided by g of x. And I'm going to assume that my g of x is not equal to 0. So we're going to assume we're not plugging in 0. For this one, because it's a fraction, I usually do work across so that I can replace it. So f of x, the right-hand side is x plus 5. G of x, the right-hand side is 4x squared. Now, there is nothing else I can do with this. I have a binomial divided by a monomial. If I wanted to, I could call this x over 4x squared plus 5 over 4x squared, which really doesn't let me do too much aside from saying that this is 1 over 4x plus 5 over 4x squared. Honestly and truly, I would leave it like this because I've got one term in the bottom, and the rest of it is not looking too bad. All right, so then the last one that we're going to do right here, then we're going to give you some more notes on other ways of combining functions or operations with functions. So this is going to be g of x. I can put a little times sign if I want to remember that it's a times, and h of x. Okay, g of x, the right-hand side is 4x squared. The h of x, I'm going to put it in parentheses so that I don't need my dot in between them for multiplication. This is 2x squared minus x. This needs to be distributed. So to simplify this, I would have to distribute it. So it's going to be the 4x squared times 2x squared, which is 8. 4 times 2 is 8. And then there's x, and there are now 4 of them. And then a positive times a negative is a negative, and 4. X squared times x is x to the third. And they're not like terms. That is all I can do with that. And then I would work on the next type of stuff. Okay, so the last type of operations that we really start looking at are compositions, and those are functions into another function. So it's just another evaluate or a substitution, and we write them as f of, so it's read of, so it's FOG, which is f of g, and then we can say of x. So it's the function f of function g. Now, the easier way to write it is to think of like nested parentheses. So the variables don't change the functions don't change any order. It's still the same way. So it's f, g, x. And we're going to work our way out from the inside out, just like you would if you had a bunch of nested parentheses. You'd do the insidemost stuff and work your way out. So you always start with what you have here. So this would be start with this one. Okay, so you inside out, get the answer. And plug into the outside. And plug into this one. All right, so we do have a couple examples of it. So still using our f of x equals x plus 5, g of x equals 4x squared, and h of x equals 2x squared minus x. I am going to do the first one, which is f of h of x, which I would rewrite as f parentheses h parentheses x. Now, replacing what I know, h of x, I can replace it with its right side. So this is going to be the f equals, and instead of h of x, I can replace it with its right-hand side. So this is going to be 2x squared minus x. And now this is like those evaluations that we had before. We're going to take the f function. So every time I see an x, I'm going to replace it with this 2x squared minus x. So I have the x. So I've got parentheses 2x squared minus x. And then I still have the rest of the expression, which is the plus 5. And now I didn't really need those parentheses, so my actual answer is going to be 2x squared minus x plus 5. And that is f of h of x, meaning I took the h function, I plugged it into f, and it simplified down to 2x squared minus x plus 5. All right, so we're going to do another one just to make sure that it makes sense. So this time it's the g of f of x. So that would get rewritten as g parentheses f parentheses x. And then we're going to replace the innermost stuff first so that f of x gets replaced. So I still have that g parentheses. Instead of f of x, I'm going to replace it with the right-hand side, which is the x plus 5. All right, so now I'm doing g of x plus 5. So that means I go into the g function, which starts with a 4. I'm going to actually put it like over a little bit. Okay, so g of x plus 5 is going to be, the g function starts with a 4. So it's a 4. I come to the x. Instead of the x, I'm going to put the x plus 5. And I have a squared from my equation. I do need to simplify this. So this becomes 4. Remember, when I have a binomial or anything more than a single term in parentheses with an exponent, I do need to write it that many times. So x plus 5 times x plus 5, and then FOIL it out. So you have the 4 hanging out, and this is going to be the x squared plus 10x when I combine my like terms, plus 25. Make sure you FOIL it out and you double check that I have it correct. And then I distribute the 4, and my final answer is going to be 4x squared plus 40x plus 100. All right, so we can simplify by combining functions. We can do operations of adding, subtracting, multiplying, and dividing. Remember, when we're dividing, we do have to make sure that the bottom does not equal to 0 because we can't divide by 0. Remember, when we subtract, that we do change the signs of everything that is being subtracted. And just be careful, watch your signs, do your simplification. Remember that function notation does not mean multiplication unless I want to do like function G times function H. And then we always have our notation tells us what variable we're going to see or what number we're going to replace in there. We might do, yeah, I think that should hopefully answer your questions. Remember, if I replace that X or that whatever we have in those parentheses with a number, we would be plugging in that number first. So you can always plug in for a number first, get that value, and then plug in again. So some of them will get a little bit easier. Some of them will be a little bit more confusing, but we should be good with that. So that is the overview of the main points of functions with function notation, evaluating, and operations and composites of functions. We do have a little bit extra stuff with it, but these are the basic big ideas that we have. So make sure that you understand how functions work, how to evaluate them, and how to add and subtract them, multiply, divide, do your operations, and then what the composite function means.